Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 2-7, solving absolute value inequalities. Alright, so the absolute value of a number is the distance from 0 on a number line. The absolute value is always the distance that number is from 0 on a number line, so it is always positive because distance is always positive. To solve an absolute value inequality, you rewrite the inequality as a compound inequality. Alright, so let's look at this. Solve the inequality. The absolute value of x plus 2 is less than 5. So the first thing that you always want to do is you want to isolate the absolute value bars, which means you need to get rid of that plus 2 by using opposite operations to move it to the other side. So we are going to start with our problem, and we are going to subtract that 2 from both sides so that we can get the absolute value bars isolated. So 5 minus 2 is 3. All right? So the absolute value of x is less than 3. Write a description for the solution of the inequality. All numbers that are less than 3 units from 0. Draw a graph of the solution on a number line. Okay, well, anytime that we have absolute value bars, we actually just drop the absolute value bars and set it equal to the positive and negative number. Like, just think about it as like 3 and negative 3 would both satisfy this, right? Well, actually, technically in this one, let's see. The absolute value of x is less than 3. So if I was doing an equal sign, then this would be 3 or negative 3, right? X could be 3 or negative 3. So we're going to go on negative 3 and make an open dot, and we're going to go on 3 and make an open dot. And it's going to be all the numbers that fall between there. So, like, think about it. If you put 2, the absolute value of 2 is 2, and 2 is less than 3. Or negative 2, the absolute value of negative 2 is 2, and 2 is less than 3. All of the numbers in between here, even if you turn them all positive because of the absolute value, they all still are going to be less than 3. Use the graph to write the absolute value of 3 is less than 3 as a compound inequality. So, x is greater than negative 3. And x is less than 3. So you could write this as negative 3 to 3. Negative 3 is less than x, which is less than 3. It's an and. It's shaded in between. Ands are shaded in between. How did you decide to use and or? And is shaded between, or is shaded in opposite directions, right? And is shaded between the two values. Solve the absolute value of x plus 2 is less than or equal to 5 by rewriting it as a compound inequality. Show your work. Okay. So, on this one, we already have the absolute value bars isolated. So I'm going to go like this. So just like if it was an equal sign, you set it equal to the positive and the negative version. But when you do the negative version, you have to flip the sign. So subtract 2. X is less than or equal to 3. X is greater than or equal to negative 7. So let's think about this. 0, 3, negative 7. Close dot, shaded this way. Close dot, shaded this way. This is definitely an and. So I could write this together. Negative 7 is less than or equal to x, which is less than or equal to 3. On the negative 7, the alligator was eating the x. It's still eating the x. On the negative 3, the alligator was eating the 3. Or sorry, on the positive 3, the alligator was eating 3. So this is an and it could be written this way. Solve the inequality. The absolute value of x minus 3 is greater than 2. All right, so we write the problem. We're going to add 3 to both sides to isolate that absolute value bars. So the absolute value of x is greater than 5. All real numbers greater than 5 units from 0. Right? So we are going to do a open dot on the 5. And we're shaded this way, right? Greater than 5. Well, let's think about this. So we really have the absolute value of x is greater than 5. Your problem could be x is greater than 5 or x is less than negative 5, right? So it's greater than 5 or less than negative 5. Because the absolute value of negative 6 is 6, and 6 is greater than 5. The absolute value of negative 7 is 7, and 7 is greater than 5. So we have to also include those negatives because of the absolute value bar. So in order to write this, do you guys see how these are going opposite directions? This is definitely an OR. So x is less than negative 5, or x is greater than 5. How did you decide whether it was an and or an or? It's an or because the solutions are going in different directions. They are not the values between the points. X minus 3 is greater than or equal to 2. X minus 3 is less than or equal to negative 2. You guys see how I took the inequality? It was already, the absolute value bars were already isolated, so I just dropped them and rewrote it, and then rewrote it with flipping the sign and making the other side negative. X is greater than or equal to 5. X is less than or equal to 1. Let's think about what this looks like. We have 1, 0, 5. On 5, it's a closed dot shaded towards the positives. On 1, it's a closed dot shaded towards the negatives. This is definitely an OR. Write a generalization for absolute value inequalities that relates the inequality symbol to the type of compound inequality that represents a solution. Okay, so when the absolute value inequality has a less than or equal to symbol, the solution will be a compound inequality involving and when the absolute value inequality has a greater than or equal to symbol, the solution will be a compound inequality involving or. And that is all of your notes on 2.7, solving absolute value inequalities. Be aware that the textbook publishers practice problems for 2.7 are the same as 2.5, so do not do those. We are going to do textbook assignment instead on page 145 to 146, 3 through 48, multiples of 3. Once again, that's page 145 to 146, numbers 3 through 48, multiples of 3. Have a great day. We hope you enjoyed this lesson. Please like and subscribe.